While ENSO is the most well-known of the global oceanic oscillations, there is one major oceanic oscillation that is closer to home, and I use this significantly in my long-range winter weather predictions. That is the Pacific Decadal Oscillation. This is meteorologist Tannis Leach bringing you PNW Weather 101, Episode 3, going over the PDO. So, what is the PDO? The PDO looks at what I like to call the horseshoe-shaped sea surface temperatures, comparing it to the north central Pacific. So the horseshoe shape goes from the coast of Alaska, going south to California and back out into the open Pacific, essentially hugging the west coast of North America. The positive phase, those coastal west coast temperatures are warmer compared to the rest of the Pacific when you're looking at the anomalies. The negative phase, the coastal west coast temperatures are cooler than the rest of the Pacific. Now, on average, the temperatures closer to the coast will be in general cooler because of the influence of the California current, which is a cold oceanic current that hugs the west coast of North America, which is why we look at the oceanic anomalies rather than the actual sea surface temperatures. And then also, this is comparing it to the global mean anomaly. So, if overall the global mean oceanic temperatures are above average, that gets wiped out when you're looking at the actual PDO values. And just for some further details on the PDO before going into how it affects the PNW, it can stay in a phase on average for about 20 to 30 years. However, that doesn't mean spikes with a short flip to the other phase are possible in the middle of those 20 to 30 years. Most commonly, ENSO influences that, as a negative PDO happens a little bit more often with a La Nina, and the positive phase tends to happen a little bit more often with an El Nino. And if you remember, for those who watched my last year's winter weather predictions, I found it very difficult to find analog years that had both a negative PDO with a El Nino, as there has not been a single strong El Nino that has had a negative PDO until last winter. Also, while I don't have it on this slide, the position of the Aleutian Low, which is a semi-permanent low-pressure system in the upper atmosphere around the Gulf of Alaska, can also influence where the PDO phase could be. Also, the effects of the PDO is very similar to the conventional ENSO thinking. The negative phase tilts the scale to colder and wetter than normal, while the positive phase tilts the scale to warmer and drier than normal. Now, the PDO is a more recent discovery, being discovered in 1997. So, as a result, there's not been as much research into this oceanic oscillation as there has for El Nino and La Nina, which is part of the reason why the main causes are being debated. Now, looking at the positive phase PDO and the temperature departures, you can see over Alaska, pretty much all of Canada, and the western US shows above normal temperatures, and on the eastern half of the US shows below normal temperatures for the positive PDO. And looking at the precipitation departures, it's a little bit more difficult to see, but for the Pacific Northwest, specifically the Cascades and westward, shows significantly below average precipitation, while the further north you go into the coastal ranges of northern BC through Alaska shows above normal precipitation. And the only other area in the US that has a significantly below normal precipitation area is right around the Ohio Valley, though the Northern Rockies also has a little bit below normal as well. Generally, this is the opposite for the negative phase. Now, going on to some ENSO and PDO correlations, and this was from a study about 2007. So, first off, I will explain that this is the precipitation compared to normal in each of the climate zones. So every state has distinct climate zones that are similar to others nearby. So for Oregon, for example, we have a coastal climate zone, a climate zone for the Willamette Valley, one for the North and Central Cascades, etc., throughout the rest of the state. So for the legend, in black is 115% of normal or higher. Darker gray, which is kind of hard to distinguish from black, it's easiest to see with the El Nino and cold PDO combination, is slightly above normal. Light gray is slightly below normal, and white is significantly below normal. So, starting with El Nino, and typically you'll see a positive PDO during that time. You get a quote unquote conventional El Nino with slightly below normal precipitation throughout all of Oregon and Washington, with significantly below normal in the Oregon Cascades. But when you factor in a colder PDO in the negative phase, Oregon suddenly flips to slightly above average, and so does the Washington coast, signifying that the PDO actually is more important than we give it credit for, and it's important to look at this for long range predictions. Going on to La Nina, a La Nina with a positive PDO also shows slightly below normal precipitation for all of Oregon and Washington, with the exception of the lower Columbia Basin. A La Nina with a negative phase PDO, however, shows significantly above normal precipitation for most of Oregon and Washington, with a few isolated climate divisions showing slightly above normal. But when you go to ENSO neutral, it's a little bit more chaotic, as while the western valleys of Oregon shows slightly below normal precipitation for both PDO phases. Going into Washington, a negative phase of the PDO shows slightly above normal precipitation there compared to the positive phase showing slightly below normal precipitation. Going on to the Palmer Drought Index, which is different from the normal drought monitor, as that only shows how dry an area is. This also can show if an area is abnormally wet, and also does not use solely rainfall. So it also uses snowmelt, soil water content as well, just to name a couple of factors. Again, starting with El Nino, and black, just for reference, is the wettest category, and white is drought is likely. So El Nino with a positive PDO shows pretty much all of Oregon and Washington, with the exception of Southern Oregon being at higher risk for droughts, while that negative phase of the PDO flips Oregon into a little bit wetter than average when it comes to soil content, especially, and the ski areas tend to do better in a cold PDO compared to a positive PDO during an El Nino. So that also goes into that. That is not the case in Washington, which tends to do pretty similarly regardless of the PDO phase if an El Nino is present. For La Nina, pretty similar story, how a positive phase of the PDO shows drought being a little bit more common, while a negative phase of PDO shows that pretty likely to be abnormally wet. And for ENSO neutral years, pretty chaotic. Some areas are more moist than average, while some areas are more drier than average. Looking at the positive PDO phase for the Willamette Valley, it shows it as slightly wetter than average, but for the negative phase of the PDO, drought is more likely. Going on to the statistical correlations between the ENSO phases and PDO, and just for anyone who doesn't know what a t-value is, t-value shows how well it is correlated, with anything 95% or higher being statistically significant. 90% or higher is significant, but not significant enough to reject the null hypothesis, which in statistics, the null hypothesis is always something neutral. In this case, El Nino and PDO would not be correlated looking at these top two maps here. So let's start with El Nino and precipitation. You could see in Oregon that it's showing, I believe that is the black color, though it might be light gray. It is very difficult to see. As a result, that shows a significant correlation between PDO and El Nino. So does the Palmer Drought Index. That does not apply when you go into Washington, signifying that there are likely other factors to consider. Same deal with La Nina, but now it does extend into the western valleys of Washington with both precipitation and the drought index. But for ENSO neutral years, again, showing how chaotic it is, except for areas in the southeast Oregon region for precipitation and the leeward sides of the Cascades for the Palmer Drought Index, there isn't a significant enough correlation to reject the null hypothesis that there isn't something else at play, with most climate zones actually being in this white color. To me, that signifies that ENSO neutral years are not solely determined based on the PDO, and other factors need to be considered. And that also furthers my belief that ENSO neutral years are the hardest years to forecast for when it comes for the upcoming winter. So that is it for this video. And speaking of the upcoming winter, well, welcome to Meteorological Winter. My December updates for my long-range winter weather predictions will be coming out in about 7 to 10 days at the latest. So be on the lookout for that. Otherwise, stay safe out there and take care. Oh, and I will link this study in the description down below if anyone's curious on the deeper findings.